there was someone on the trip, I can't remember who, but I think Brian, he brought up a very interesting point and he asked you about this. Many of the homes and the construction sites we saw seemed like they had used an excessive amount of material, like 2 feet thick walls, 2 feet thick floors, ceilings. It was to an American that's used to stick building and walls that are mainly
three and a half, maybe 5.5
if you're
inches thick
lucky,
at
yeah.
most. Yeah.
It seemed like the amount of material that went into one site could have been used for an equivalent 3 or 4 units in the States. There was that much material that went into one particular unit, one particular building. And someone on the trip brought up a point about front loading carbon. And they asked you about this. And I thought that was very, very insightful because yes, it is resource efficient in terms of energy use over over the life of the building. But what about the amount of energy that goes into building it up front?
So that conversation is operational versus embodied energy. So this is an area where our industry is really just starting to dive in and kind of sink our teeth into what this means. And it's a question that's happening all over the place right now. And what we're seeing is that it's a balancing act. So the aha moment for me was about 10 years ago. I was at a Northeast Sustainable Energy Alliance conference, and I saw Jacob Reck-Houston from New Frameworks out of Vermont gave a discussion where they looked at the embodied carbon of a passive house building that they had just constructed. So the building was going to consume about 80% less energy, which is great. Operational energy was decreased, but when they looked at the embodied energy that went into it, it would take 150 years of that building's energy savings to offset the embodied energy that went into creating it. So what that means is
150 years.
50 years to hit parity before it was doing any sort of environmental benefit. So what that means is in that 150 years, we can't modify it. We can't change anything on it. It has to be steady state 150 years before that building does anything for the environment. That was kind of the aha moment. And what they broke it down to is that it had a high reliance on plastic foam insulations, spray foamed insulations, steel, glass, plastics, concrete in order to achieve this particular building. Jacob has then gone on with Chris Magwood of the Endeavor Center and created this beam calculator and done a lot of really fabulous work on embodied carbon in buildings. And what we're finding out is if we're smart about our material choices, we can make buildings actually carbon parity at construction, or even buildings that store carbon at the time of construction. That being said, this question is something that we have to pay a lot of attention to right now, because if we're looking at what climate science tells us, that we have 20 or 30 years that we have to kind of start turning the tide back towards, energy conservation. If we're front loading it by making all of these materials right now, we're actually speeding up climate change and putting ourselves into a worse situation. So it's kind of a scary thing to say, but there is a time where a high performance building that's using high embodied energy materials is worse than just a code built building for the environment.